All right, so today what we're going to learn about is, or go over, is a practice problem of doing limiting reagents. And so this is a limiting reagents problem. I'll write it up here. So this is a limiting reagent problem. And so the way we know this is a limiting reagent problem is that you're generally given the grams of one compound and the grams of another compound, and we have to figure out and solve for the grams of another compound, right? And that is usually the dead giveaway as to if it's a limiting reagent problem, is that you're given 2 gram values for 2 different compounds. And so this is set up like a 2 stoichiometry problems back to back and then comparing the answers at the end, right? And so if this is just like a stoichiometry problem, our first step is to always balance this chemical equation. And so our job is to balance this chemical equation. At this point, I kind of assume that you're able to balance this chemical equation. And so you probably get the coefficients of 1, 3, 2, 2, and that gets us the same values of N's, H's, and O's on both sides. And so we have now done step 1 already, which is balance this chemical equation. Our next step is that we want to start off with the entire first half of this problem. And so this is going to be the entire first half of the problem, which is using this half. And so this will be the first half. Is using all the information about our 128.24 grams of N2H4. And so our first step for here, so I guess step 2, is that we are given grams of N2H4, and we have to go to moles of N2H4. And so whenever we go from moles or grams to moles, we divide by the molar mass. And so we need to know the molar mass of this compound, and so I'll make a list over here as to the molar masses of all these compounds. And so in this case, we need to know the molar mass. I'll do this, actually, I'll keep it in this color. The molar mass. And so of this compound is going to be N2H4. And at this point, I kind of expect you to be able to solve this as well. And this is given to us as 32.06 grams per mole. And so whenever we go from grams to moles, we divide. So we have 128.24 grams of N2H4. And we have to use a ratio to get us to moles of N2H4. And so we divide by the molar mass. And so this would be 1 mole over 32.06 grams. An easy way to know is that since we have grams here, that is the unit that we want down here. Since we want moles, that is the unit up top. And so if we do the math, it is going to be 128.24 divided by 32.06. And you should get exactly 4 moles of N2H4. Then our next step is to go from moles. So now that we have moles of N2H4, we want to then go to moles of our compound that we really care about, which is NO2. And so moles of NO2. And so this is by using the ratio from the balanced chemical equation. And so in this case, we have 4 moles of N2H4, and we have to use a ratio to get us to moles of NO2. And what we do here is, since we start off with N2H4, that is what we want on the bottom, so moles of N2H4 on the bottom. And then since we want moles of NO2 on top, we write that up top, moles of NO2 on top. And then we use the balanced chemical equation to look at these values. So what number is in front of N2H4? That is 1. And so we write a 1 down here. And what's in front of NO2? In front of NO2 is 2, and so we write a 2 up here. And so we do the math, which is 4 times 2, which is 8 moles of NO2. Then our last step in this problem, I can do this in red here, or for the first half, 4, is that now that we have moles of NO2, we could then go to grams of NO2. And this is once again by using the molar mass of this compound. So we this time are going to multiply by the molar mass. And so we need to know the molar mass of NO2. And once again, I kind of expect you to be able to do this. And this is equal to, I believe, 46.01 grams. Let me just double check with my calculator that this is correct. And I got 46.1 once again as the gram value. And so this is correct. This is going to be grams per mole. And so what we have here is 8 moles of NO2. We then multiply by a ratio to get us to grams of NO2. And if we do this correctly, once again, we have to use a molar mass. This is going to be 46.01 grams over 1 mole, right? And so we just do the math. Remember, if you want to double check this work, units that we want is on the bottom, so moles is down here. Since we want grams, that's up here. And let's put this into our calculator real fast, and we get 8 times 46.01. And that is equal to 368.08 grams. And so for our first half of our problem, we get 368.08 grams of NO2. What we have to do in a stoichiometry problem, or in a limiting reagent problem though, is do this twice, right? And so what we have to do then is steps 5 through 7, which is kind of repeating the process. And so I'll write it over here. So 5 is that now instead of dealing with the first half, which is all about the mole or grams of N2H4, our second half, I'm going to actually color this or change this color real fast in red just so that we can clearly see. So our second half, we're focusing directly on this portion of this. So our second half is all about our 32 grams of O2. I like to use the same colors for step 5 as the same color as step 2 because it's the exact same process. Is that we're going from in grams of our compounds, this will be O2 instead, to then moles of O2. And that is our first step. And so we need to know the molar mass of O2. I'll write that over here. O2, that is equal to 32.00 grams per mole. And so the way we have to do this is we have 32.00 grams, use a ratio to get us to moles of O2. And our ratio is going to be 1 mole over 32.00 grams, right, from our molar mass. Remember, easy way to know this is that grams goes down here. And so we have 32 divided by 32, so we have 1 mole of O2. Then step 6 is the exact same thing, is that we're going from moles of the compound that we have right there, which is O2, to then moles of the compound that we care about, which is NO2. And so we then go from our 1 mole of O2, use a ratio to get us to moles of NO2. And the way we do this is, once again, look at our balanced chemical equation. So what number is in front of O2? Or actually, let's write this thing out. Remember, O2 is going to be on the bottom, right? Because that's what we start off with. What we want is moles of NO2. So that's what's going to be on top. And the values in front of that is 3 and 2. And so we write a 3 down here and a 2 up here. And so we get 1 times 2 over 3, and that is equal to roughly 0.67 moles of NO2. And then lastly, our final step, step 7, is that we go from now our moles of NO2 to grams of NO2. And so in this case, we have 0.67 moles of NO2. And we have to use a ratio to get us to grams of NO2. And so once again, we just use the molar mass of NO2, which we have up here as 46.01. So we write 46.01 grams for every 1 mole. And so we have 0.67 times 46.01, and that is equal to 30.67 grams of NO2. Let me just double check. I believe that's the correct value. And so let's look at that real fast. So 0.67 times 46.01, and I got roughly the exact same value. So 30.67 as our final answer. And so now we have two different values, right? We have, I'm going to do this once again in a different color. Let's go back to our blue color. We have this value right here of 368.08 grams of NO2. And we also have 30.67 grams of NO2. And so the correct answer is always going to be the lower of the two values. And so this one right here is our actual final answer. And so what we describe is the compound that results in the lowest amount of our grams is our limiting reagent. And so that has to do with our second half of our problem. And so that's going to be our grams of O2. And so we describe oxygen, or O2, is what we call the limiting reagent. And so it's the limiting reagent. And then our final answer is going to be 30.67 grams of NO2 as our final answer. And so what I like to do is I like to box this. And then a lot of the times as well, I like to write this as our final answer. So this is going to be the final answer. So that we know that instead of these other two boxes, that this box down here is our real final answer.